All right, very good. Well, thank you, Osni. Welcome everybody to this workshop, and we look forward to presenting information to you, but also taking any questions and comments, especially input you might have. We're learning as we go with this activity, and we have a lot of really talented people involved in this effort. But it's a new space. It's a new design space for us, new implementation space, and we welcome community input as we go forward. In fact, we really can't succeed without your active engagement in what we're doing. And we're very, with the facility staff, we're very pleased with our interactions so far. We're especially pleased with the interactions that we have with NERSC and the staff there. And so I'm going to get started by giving a bit of an overview of the software technology focus area within ECP. And then you'll hear from others in a lot more detail about the activities that are going on. So let's get started. I want to give a little bit of an organizational sketch so you can have a bit of a mental model of how ECP is organized and where the software technologies and the E4S activities fit. So ECP has three what are called focus areas. Application development, hardware and integration are two areas. In fact, you'll hear the collaboration we have going on is a very strong collaboration between software technology and hardware integration, and then the applications, which are the focus of why we're doing this work to begin with. So AD and HI are two areas, and then software technology is the area that I am the director for. And so I'll give you a little bit of detail in that. Whoops, sorry, I went a little too far. So ECP-ST, as we call it, software technology, has what are called 6 technical areas. We have efforts in programming models and runtimes. These are things like COCOS and Raja, for example, OpenMP, some work there, MPI. So these are efforts in the, and GasNet, Legion. So these are efforts to provide programming environments that applications can write to, and then we can optimize backends for the various platforms. The development tools include performance tools, for example, things like Tau, HPC Toolkit, but also a lot of our LLVM oriented activity is here. We're creating, exploring designs and implementations that we're pushing into the LLVM stack. Math libraries, so these are things like SuperLU, PETSI, and so on that provide capabilities for teams that need those kind of shrink-wrapped math libraries. Data and Viz are I/O capabilities, visualization tools, pair view related activities, but also increasingly hybrid approaches where there's a lot of in situ work being done. And then software technologies is how we focus on delivering capabilities. And so much of today's activity or discussion will be around this software ecosystem efforts. And then the sixth area is the NNSA labs, of which I'm a part at Sandia, provide a lot of open source software that is generally useful to the broader community, and it's useful to the NNSA labs to have these interactions. And so in part of our portfolio, our activities, these are libraries, for example, Spac tools like Spac, for example, there's a component of Raja and COCOS that's within this area. So we bring in these capabilities into the portfolio via this particular NNSA technical area. I just wanted to leave behind the leadership team for software technologies. If you're involved in these areas, I think these are some of the key technical people within the DOE and nationally and internationally in these areas. So we're very fortunate to have some very solid people leading the technical areas within software technology. Again, a sketch of the software teams. We have roughly 250 staff members. We make contributions to about 70 products. And we have 34 teams and so on. You can kind of read more of the stats as we go forward here. But again, this is kind of a leave behind. And the big activity is that this is a big team, and we're doing things in a fundamentally new way, in particular as a portfolio of products that we're contributing to. And so that it's this portfolio approach that is really fundamentally new. Just to give you some sense of what we work on a lot of things that you probably know about. MPI-CH, one of the more popular MPIs, especially with the vendors, OpenMPI, PETSI, the libraries. When the project got started, when ECP got started, Cocos, Raja, Spac were maybe lesser known names through the activities of ECP and certainly other activities as well. These have become kind of household names as we approach the end of ECP, maybe at least within HPC households, maybe not broadly, but I think you understand what I mean. And then also there are new efforts that are emerging. SICM is a simple interface to complex memory. ZFP is a compression library. Unify CR provides rapid kind of in-memory or solid state IO capabilities. And then all of these products that are here on the list here that I won't go through in detail. Just to give you one example of many, SLATE is an effort to port dense linear algebra capabilities. Now, SLATE has been around for a while. Their capability is provided for NVIDIA platforms, but one of the big legacies of ECP will be taking capabilities that have been available in CPU environments and maybe NVIDIA environments, and then making them available across 3 different software hardware stacks. And that's the NVIDIA environment, the AMD environment, and the Intel environment. In fact, it will be one of the big legacies of ECP is that we're providing libraries and tools that work across these 3 different GPU architectures and improve the overall quality and diversity of the HPC landscape because of these kinds of efforts. It's very likely that we'll have several revs on GPUs going forward past ECP, and GPUs will continue to be one of the most important HPC device targets with our efforts as we go forward. I want to talk a little bit about planning, executing, and delivering, because again, we're a portfolio, and so we can plan at a level that was not possible before. ECP is considered a federally funded construction project. It's a 413.3B federally funded construction project. Now it's tailored. We were given latitude in how we interpret the construction aspects of it, especially because it's a software project. It's an R&D software project. But we did put out a baseline plans starting in FY19 for the entire remaining span of the project in through FY23. Now that baseline plan was the equivalent to, say, if you're going from where I live in central Minnesota to the West Coast, it would be go west. And maybe you'd have speculate as far as, what does it mean if we have to be done in 23, provide these capabilities? What's a notional sense of where we would be, year to year? And then we do an annual refinement, and that is taking that, what we call a planning package for that year, and refine it down to a handful of more specific activities, because we can see better, as the year approaches, what we need to do. And then per activity, we add the final detail. And this happens 8 weeks prior to the start, where we put in the detail of what we're going to do, who's going to do it, what are the completion criteria for getting it done. Now, of course, when you plan multiple years in advance, you can't perfectly see what is required. And so we have a kind of 2-level review process to change the cost, scope, or schedule of what we're doing. There's a minor review, which is lightweight. If you have to do something that's pretty straightforward. If there's something pretty substantial, then we put it through what we call a change control board. That reviews it and get a bunch of eyes looking at it and try to reason about what needs to change and why. And we like this general, well, like is maybe too strong a word. We appreciate the value of this kind of effort and improving the rigor of our work and making sure that everybody that needs to know what's going on is able to find out and provide some input. Of course, we're learning as we go. I think the process has improved a lot, both by becoming lighter weight, but also providing additional value compared to what we were doing in the beginning. In addition to this planning, we have a quite substantial and I think an improved process for declaring value. What is the value of the work that we do? And it's a focus on sustainable capability integration. So we provide tools and libraries to the community. What does it mean for something to be useful? Well, it's used in the client environment, and that is sustainable, and that, if someone wants to depend upon it, we've put in the effort and the commitment to make it available as we go forward in time. And so by focusing on not only just planning what we're going to do, being thoughtful about the effort and tracking our progress against the plan, also being able to say, okay, we've done this work, is it impacting the community? And so this capability integration approach ends up being the core focal point for, are the products that we're doing, maybe they're, beautiful software, but if no one's using it, then that doesn't mean as much. And so this focus on capability integration is the key. If you take the what we're called P6 activities, it's a technical name, but basically you can think of it as our planning process within software technology. If you take that and then you put that on the front end of our life cycle, and then you put KPP3, which is the capability integration as the second part, we cover by these two basic processes the full life cycle of the macro engineering that goes on within ECP software technology. I'll talk a little bit about E4S and the SDKs, although many, the subsequent talks will talk about in detail. So I'm just going to go into this stuff in a brief sense as we go forward, giving you a bit of an overview. So E4S stands for the Extreme Scale Scientific Software Stack. It's been around now for a few years. We have committed to quarterly releases. The last release was in August. It includes all of the products that ECP software technology is contributing to, and other products as well. It's really you can think of it as a high performance HPC Linux environment. Right now, although we do care about Windows eventually too, and other Unix platforms. It includes all the things that we're working on, plus other products that are in particular products that are maybe a bit hard to install. PyTorch, TensorFlow aren't so hard to install, but Horavad, which provides distributed memory AI capabilities, is a little bit harder. So having those things as turnkey is important. It also includes some of our co-design teams, which are part of the application development portfolio, but this is Amrex, Cabana, and MFEM. These are products that are coming out of the application space, reusable frameworks for applications. Those are also part of E4S. In addition to E4S, which is the whole thing, the whole portfolio, we're creating a layer of interoperability and community collaboration through what we're calling SDKs. SDK is an overused term, has multiple meanings, but in our case here, what we're doing is we're bringing teams that are developing similar capabilities, collaborative capabilities, and having them interact. Do some planning together, do interface development that allows them to more easily leverage each other's capabilities, do tutorials together, documentation together. The math libraries areas had this kind of model for interaction for quite a few years now, and it's the most advanced, but we're integrating this type of model into other product specialized portfolios as well. And we see the value of this kind of work in lots of ways, and improving the usability of the tools. These teams learn from each other. They're still providing the individual products, but they're higher quality. They're easier to use. The documentation allows you to see, across the product suite as far as what is useful. And it creates this kind of sense of co-opetition. So people like to cooperate with each other so they can learn from each other and be compatible with each other. But there's also a bit of competition because you now see your product in the light of other products and you want to do your best job. And so there's a lot of, I think, positive dynamics with this kind of approach using SDKs. So the E4S and the SDKs introduce 2 new layers into how our reusable libraries and tools are being provided to the community. The lower level, the individual products, that approach to delivering software has been around for decades, and it's a very effective way to do things at an individual product level. But the addition of the SDKs and the addition of E4S allow us to do some really powerful portfolio level activities that overall improve the work that we're doing. I'm going to talk about a few more things about E4S that may not be touched upon so much in later presentations. The first is our community policies. One of the things that we try to do with E4S and with the software technology area in focus is create a set of expectations about the quality of the products that we're providing, how we interact with the community, what kind of service they can or support level teams can expect from us. And so we've created this set of policies. If you go to e4s.io, you can see across the top panel a policies statement. You can tap on that, and what you'll see then is this list. Now right now there's just 9 policies, but these have been vetted and have grown out of the development community itself. So basically the teams within ECP software technology have agreed that they can support these kinds of policies and the quality commitments that come with them. And so these are accurate statements there, but they're not very prescriptive because they're sit at the very highest level of E4S. You can look at the X SDK, the Math Libraries SDK. They have a set of community policies that are more prescriptive, more precise, and longer, more of them, but they're compatible with these 9s. And so what we're trying to do is build this general notion that we can expect quality from the products that are part of E4S. This is version 1. And so we anticipate going forward that we will have additional versions that are, more expansive in what they cover, maybe more prescriptive in what they cover, but we also expect to see at the SDK level additional policies emerge. I want to also mention the doc portal, which is our effort to provide a single point of access to the documentation of the products that are part of E4S. We do not replicate the documentation that the teams provide. Instead, what the doc portal does is it takes a single URL pointing to the repository of any product, and it goes and looks for metadata files. It looks for your README file. It looks for your license file. And then increasingly, we can tell teams, okay, if you want to provide additional information, for example, how your product is supported, here's a special file you can create with that information. We will rake for it and we will render it in this product doc portal list. And so it's a searchable, portable, it's sortable by a variety of things. And increasingly, it has additional information. We now have a timestamp, for example, that says what the last time that it was updated. So you can get a sense of the freshness of the information. Is somebody paying attention to the documentation on this for this particular product? Just as an example, if you take audio 2, you click on it, you can see a summary list. Again, this is raked. This is always fresh information if it's fresh in the repo itself. And then if you tap again, you can go to the documentation site for audios. And so this is our way of providing one portal that gives you access to a layering of information for the products that are part of E4S. Okay, just a summary then a bit of what we're providing with E4S. We're going to go into some of these things in much more detail. We have the community policies, the doc portal. We do portfolio testing. I'm not going to talk too much about that. I talked about the curated collection, quarterly releases. I didn't talk about build cache. It's a very exciting topic. which we'll get to. And we're hoping that this kind of approach will provide a turnkey stack for people to depend upon, so that you can use E4S as a pre-built capability for you, or build it yourself if you want to, or in a cloud environment. Lots of different ways to get access to it, and lots of different platforms. And then I'll talk briefly about how we're engaging the broader community and what we're calling the Leadership Scientific Software, or LSSW, activity, and we would like your engagement in that as well. Okay, so a little bit about growing and sustaining the software community. As you all know, having good people and being able to collaborate together effectively is absolutely essential as we go forward. One of the key activities within ECP has been the Ideas Project. Now, this is not officially part of software technology, but a number of people within, including Lois Kerfman-McGinnis and myself, are part of the Ideas Project. And you know about the Ideas Project, I hope, if you've seen things like the HPC Best Practices webinar series. Maybe you've been involved in some other activities related to improving the quality of your software, or the teams that you're a part of. The Ideas Project has been involved in these kind of social elements that are going on, and how to improve that. We also have a fellows program, because we think, again, kind of creating the awareness of the activities and the people who contribute to this area, and also expanding the diversity of the community that can be a part of the high performance community itself, we think is very important. And these fellows, the fellows program, BSSW, is one of our ways. The BSSW fellows now also includes candidates from the National Science Foundation. We've combined and worked with them to merge efforts in this area. This is a report that comes out of the Ideas Project if you want to see more details about what we're doing here. Okay, the last main topic is I want to talk about lssw.io. So ECP is going to end in a few years here. And so we want and are very urgently focused on what comes next. And LSSW is a key component of trying to figure that out. So ECP is ending soon in a couple of years. We have E4S. During the final years, we're trying to establish, what does it look like after ECP? And so LSSW is one key component. It's to build community and understanding around development and sustainability of leadership scientific software. It's a portfolio-driven approach. The idea is to create sustainability organizationally by improving quality and accessibility to the products that we're working on. It's about libraries, tools, and environments. Yes, it is about applications. I mean, ultimately, that's what we need to service. But our focus is to try to make the substrate that helps the application teams more sustainable, more usable, so that it's more attractive and can be used by the application teams as they go forward. We want to push the boundaries of feasibility. We use the term leadership to mean software that has a focus on the next generation platforms, next generation problems at scale. So it includes things like modeling and simulation on leadership platforms, but we also foresee that it includes things like edge computing and the needs for edge computing, scientific AI, where that occurs at scale and interacts with modeling and simulation, even quantum, where it fits in, within the scientific endeavor. And so we're focused on leadership, not because we exclude non-leadership capabilities at all, but it has to have some component of that, because co-design is an important part of what we're trying to do with leadership software. And the ECP is certainly a part of that as we try to go forward with this kind of work. And we encourage you, we would love to have you join the conversation. We have a website, lssw.io. The LSSW town hall meetings are the third Thursday of each month, and we would welcome you to participate in those. We've had one already. We had, I think, 159 people attend. And so we expect a large audience, and we expect to have these conversations. We also have Slack workspace you can join, and some mail lists that you can join. We would love to see white papers from you that talk about ideas. What do you think is important for sustainable scientific software as we go forward? And if you go to lssw.io, you can find all of this information. So here's some summaries of a summary of what I've just mentioned. I won't go to this in detail, but just again to encourage you to interact with us as we go through our efforts currently within ECP and as we prepare for post ECP. And I will stop here. Take any questions people might have or comments. Osni, do you have anything in the, I see there's one chat item. Okay. Oh, okay. Any questions?
Mike, if you'd like, participants can unmute themselves if they would like to ask you directly, if you prefer that.
Yeah, that'd be great. Yeah, and I know we're near time, and so I don't want to, if no one has questions, that's fine. We can move on and go deeper into the topics.
Is there any questions from the participants? Could use the chat, or apparently there is an issue with the Google Doc that was created for this purpose. Some permission issue, I think. But as I said, so if participants would like to unmute themselves, I think Mike has a little time there for some questions, right, Mike?
Yes, I do. Yeah, yeah.
Any questions? Otherwise, we move to the.
All right. Well, we should move along then.
There's one there, Mike.
Oh, sure.
Do you see the chat, or should I read it for you?
I do. Hang on just a moment. Okay, Chris Chang. So as software gets more complex, documentation demands also go up. What are the plans to improve documentation? That's a very good question. Thank you. Yeah, so a couple of responses to that. One is the doc portal that we're doing provides access to the documentation that's already there. It also, I think, encourages our teams, because their documentation is now more readily accessible and visible, to do a better job of managing that documentation. We're still on the front end of this, and so we're not seeing everybody step up and improve what they're doing, but we are seeing some people. Also, the community policies part that I mentioned, one of them is about documentation, and so the documentation expectations also are increasing. And what we're going to do with these community policies, in fact, at the next review that we have for our software teams, is ask them to describe, what is their status relative to these 9 policies in terms of providing, the quality expectations that are stated in the policies. And then ask them also, what would it take for you to improve? Because we want to know where the gaps lie. And what would it take to reduce or close the gaps, and maybe even provide additional funding for teams to take that task on. And so I think you'll see through our efforts to create visibility into documentation, what's available, and then increasing the expectations for quality will go a long way to improving the documentation as we go forward. So thank you. Okay, I've stopped sharing, and I think we want to move on, right?
Yeah, Shazib is gonna go next.
Okay, can you see my screen?
Yes.
Good. Okay, so for this session, I'm going to actually just talk about how you can use E4S at NERSC. And this will be kind of a mix of hands-on. So for those of you that have access to Corey, please feel free to, you can follow along in this exercise. We'll basically talk about our E4S deployments that we have on Corey, how you can access them using the module, and then actually use the software that we have installed So if you're on our NERSC documentation, just some idea, like if you don't know how to connect, there's a page on connecting. So you need to know your username, your SSH to Corey@nersc.gov, and that should hopefully get you in. So I'll give you maybe a few, some of you guys to connect if you want to follow along. If you don't have access, don't worry. You could just listen in. So our documentation for E4S is under applications. We don't know, under E4S. And then we have a main page here for E4S. So if you have kind of any questions regarding E4S, you can submit a ticket to ServiceNow. That's this link right here. If you have any specific questions about E4S, like the project itself, then please create an issue in this project link right here. So currently we have 3 versions of E4S. We're gonna have we have 2105, 2102, and 2010. And the way the documentation's, there's 1 page per tree. So there's this one right here, 2105. All of them have been built with Corey. So what we're gonna do for this session is we'll just basically talk about the documentation, how actually you can use it. So just give me a second to get set up. What is this? Why isn't this going? Okay. Yeah. Okay. So in order to use E4S, actually, let me go to 2102. This one's going to have a little bit better example. So in this session, what we're going to talk about is how you can use E4S. So there is a module load command that you have to do to activate your E4S environment. And what it does is it will drop you into a Spac environment with all the pre-installed packages. Okay. So to access E4S, there's a module load, let's say E4S 2102. So if you do module load, module avail E4S, you would see 3 different E4S environments. Can you see my screen? I don't know if I'm sharing the right one.
Yes,
You're seeing the documentation, right? Okay.
we see the doc.
Okay, good. So yeah, you have to be logged into Corey, and what we'll do is we'll load E4S 2102. Let me make this bigger. Okay. So when you load the module, what you'll have is you'll have an instance of Spec that you'll see. And in this release, we have 45 E4S products are installed. Most of them have been built with Intel 19.1, 2.254, and then some have been built with GCC. So you can do Spec find. I mean, if you want to know all the packages, you can just do Spec find. Spec find explicit just shows you all the actual products. So let's do that. You'll see what we have installed. So you'll see all the packages in this. These are all the packages that have been installed with Intel right here. And then these are some of the packages installed with GCC. And then, yeah, so there's quite a bit of software. We also have a module tree that is that shows all the generated modules for this E4S stack. So it's actually this whole path right here. And the way the modules have been set up, it's using this format, name/version-compiler name and compiler version. So in order to see the modules, you just do module avail. And I mean, there's quite a bit of modules, but if you go to the top right here, this is the module tree that you see. So when you actually load E4S, we just expose the module path. So if you do module E4S, module show E4S, we just prepend the module path so you actually see it. Okay. So next, what we'll do is so if you want to use some of the software, you have the option of using module load or Spac load. So you can use either or. It's really up to you. Okay. So first we'll talk about, so if you want to load, let's say an example is we want to load PAPI. There is a PAPI, say this Intel one. And then, PAPI provides a program called PAPI meminfo. So it just shows you the memory, cache information. And if you want to know where it's coming from, you could just do which, and it will show you that this is coming from one of the Spac packages right here, right? The other way that you can actually do is using Spac load. So if you prefer to not having to remember all these modules, you can just pick one of the Spac package. So it's called Spac load. Let's do darshan. So I'll just show how this works. We'll load darshan, and what Spac load will do is it'll update your path. It may take a little bit of time. I don't know why it's doing that. Oh. Something is wrong with the file system. Anyhow, okay, we can skip this one. There's no problem. So when you load E4S, what we do is we're in a Spac environment. So if you want to know that, you can do Spac environment st to show, and there is an environment called E4S, and this is the production environment that was used to deploy E4S. There is a mirror where we provide all of the let's say specs in the build cache. So the specs are actually in this location right here. And you can do Spac build cache list, and it will show you all of the specs. So the build cache is used if you want to install the package in your own user space. You can just add this mirror and then just install whatever you like. Okay.
Hey, Shazi, but there are two questions that perhaps I think would be a good moment to address there. Do you see the?
Sure.
Do you see them?
Yeah, I see them. Yeah, the stack has been built for Haswell node on the login nodes. So it should be compatible with KNL. For the time being, we haven't built E4S for KNL, simply because it wasn't something that we wanted to do for the time being. We wanted it to work for Haswell because that's what you have on the login node. And those ones should work on KNL. If you build on KNL, it's not most likely going to work for Haswell. What C++ language standard is used to build C++ code in this environment? I am not sure about that. I guess it depends on each application. but the compilers that were used were these ones. So Intel 19 and GCC 10. So yeah. Okay. So for this example, what we'll do is, and if you, so this would be something that you would typically do. You have your own user space where you want to install some Spac packages from the build cache, and we'll talk about how you can do that. So the first thing that you would do is we're going to create an environment. In order to do this, you need to create it in your user space. You can't use a production environment simply because you would just run into permission issues. So Spac environment create is it's got several options to create environment, and if you just do Spac environment create some name, you're going to run into an error. So what we recommend is you use the -D option and specify a location in your home directory or somewhere in Scratch, wherever you can do this. Before you create environment, I just want to remind you that you're in an environment, so you have to deactivate. So you can do that using deactivate or despactivate, that should work. And then we'll just create an environment using this in our home directory. I don't know why it's taking so long here. Okay. So if you're familiar with, like, let's say like Conda environments or something like that, you can only be activated in one environment at a time. So that was why we had to unactivate from the environment, then we activate. So it tells you how you can activate. This is basically the command that you want to use to activate an environment. And once you do that, your prompt will change, hopefully. Okay. Yeah, so for some reason today the Corey has been pretty slow. I don't know why. Okay. Yeah, so that this is under my home, my project. The next thing I would, so what happens is when you create an environment, it will write a Spac.yaml for you, an empty one. And what we're gonna do now is just remove and then copy this example. So this is a basically an example. We're gonna just install Darshan runtime and util spec. Okay, so we just quit save. The next thing that you would do is in order to use the build cache, you have to do two things. One is set your Spac GNU PG home. That's an environment variable that Spac understands to basically a location where you would want to set where to search for GPG keys. And the other is actually trusting the public key that was used to sign the specs. So if you were going to create your own GPG key, you know, generally I recommend like you just put it like in your home directory, because that's where it's generally stored. The reason why we do this is Spac puts a GPG key in its root of Spac, and you can't actually use that instance. So that's why we recommend you do this. The public key is actually in this link right here. This is something that you only have to do once. If you've done it once, then the GPG key will be saved in your home. I mean, it will be trusted. So once this is done, it would show you that this GPG key will get saved. Yes. So there was a question: is it possible to use E4S packages through Spac Upstreams or Spac chaining? Yes, there is support for that. We didn't put it in the E4S stack, but there is documentation for Spac. Where it is under. So where is it? Under developer tools? No. Build tools. So there is a separate documentation for Spac that we have. And yeah, I'll over here in Upstreams, I'll put it in the chat. There's a module load Spac that was that's the NERSC Spac instance, and it has these let's say upstreams that point to different E4S stacks so that you can use it to do Spac chaining. Hope that helps. Okay, so while I go back, so the GPG key, it has been trusted. So you can see your GPG key using GPG key -K. It will just list the GPG keys, and it will show you that this GPG key has been is available. So the public key is what we need to be able to install from the build cache. So next, what we'll do is we'll concretize the environment. So Spac concretize. You would see, yeah, Darshan's automatically, there's going to be built with GCC. In our Spac instance, we have set up the preferences for you. So that way you don't have to specify that, but if you want to override, you can define it in your Spac.yaml. It's going to use the same compilers that we built the software. So that way, if you want to use the build cache, it will be easy to do that. The Spac configuration for the site is actually in this location. So Spac etc Spac, Spac root etc Spac. That's where you have all of your site configuration for Spac, including the packages.yaml. So next, what we'll do is we'll just install. And what it'll do, it'll take a little bit of time, but it'll be pretty quick. And what it should look like is something like this, where it will try to install all the packages, and then the packages that require installing from the build cache will have this indicator plus, and it'll show you the is fetching from the build cache. So let's just see how that goes. So here, let me make this a little bit bigger. So you can see here, Darshan runtime has been picked up, and you see the GPG key has been signed right here. And then all of its dependencies like bzip2, Darshan utils. Yeah. Okay, so that's it. So now all the packages have been installed. Note that it was really quick. There was no, software that was installed from source. So the next thing is, now that you have the software, you can do Spac find, and you'll see all the packages that have been installed. Now they're installed in your user space. You can actually, I believe there is an option called -L and P. and you can show the prefix of where everything is. So the software is actually installed in your home directory. There's a directory called Spac workspace with a subdirectory software where all these specs are installed. Okay, so the next thing what we'll do is actually generate the modules. So generating the modules is a pretty simple thing. There's just one command that you have to do, which is Spac module tickle refresh. And -y just means accept yes for all the options. So it's done. So what happens is these modules have been generated. You can actually find where this is, like the path to these modules. So you can do something like -- full path, and then the name of some spec. And you'll see the modules are actually generated in your user space modules, the architecture, and then the name. So if you go to this, like, let's say this link right here, you're going to see there is one module per software. So the way you would actually expose this module is take, all the way up to here, this path, and then just do module use. And now if you do module avail, all the way to the top, you see all of the modules there. So like if you want to load the software that we just installed, like this one, you can just do module load, darshan runtime. Forget what the other darshan util module is. This one, I think you need both. Yeah, I think you get the point. So what we basically showed is how we take a spec.yaml and actually build the software. Install a package to spec.yaml through the build cache and generate the modules in your user space. And then after that, you can use the modules that you've generated and then do some and then run some code with it. If you're interested in knowing like our Spac configuration, I'll just briefly talk about this. So where is it? So I'm gonna despacktivate. So if you want to get back to the production environment, it's just E4S. So you just do Spac environment activate E4S, and yeah, you can just go to the directory where our spec.yaml is, and we'll just briefly just talk about how this was deployed. Okay. So the compilers that we have set up. So sorry, let's just go to the config. So this is the root of where the software was installed. Under software, the modules is under here. We're using Tickle for this. This is the mirror. So if you want to set up yours, if you want to use the build cache, this is the location. These are the compilers that we use. So Intel 19.1 2.254, and that maps to this Intel version, and progamv Intel. Same with the GCC. And then the E4S deployment that we have is all of these packages. So in Spac, there's a definition where you can specify a list of specs that need to be installed. So what we have is we have an Intel compiler spec and then a GCC compiler definition, where we say all packages that have to be built with these two compiler. So percent means that it has to be built for this compiler. And then we just name all the specs. So these are all the specs that need to be installed with E4S, with Intel. And then these are the ones with GCC. Oh, these are all the errors that we had. And then you just specify the matrix. So it just takes all the E4S, so all the specs and just install them with the compiler. So yeah, and then these are our packages preferences for actually for each of these specs. Okay. So we recommend, like, if you're going to use E4S, especially the packages preference, you should set that up yourself with whatever application you're setting up. But if you want to use the preferred Spac settings that we have for deployment, you can go to Spac root under etc Spac. And this is the configuration that is provided. So there is one for, let's say, the compilers.yaml. You can take this if you want and copy it. And same thing for the other ones, like config.yaml, mirrors.yaml, etc. Okay. So that's basically it on our user documentation. The other pages are very similar to E4S, so you just have to know the different E4S environments. Let me see. Yeah. Okay. Yeah, so let me, before I switch to the next session, do you guys have any questions on this? I see one question. What if I want to create my Spac environment as an extension of the E4S environment that the centers provide? Yes, that's a good question. So there is a documentation on how you do that. So what you do is you take the Spac.yaml that we have provided and you just install all the packages first. So there is a link to this. I'll put it in the chat. So how you redeploy the software. The trick is you, this is for E4S 2010. You create an environment, something like, your home directory, like let's say E4S 2010, and you take the spac.lock as the argument to create yours in your environment. That actually is going to replicate the entire stack that we have. And in the user space, you will have a spac.lock, and then you can just, install, and that should do it. You may want to add the E4S mirrors. So I think in this case, just add this and then Spac install. And then if you do it, you would see a Spac find of all of these packages. And then you can add any additional packages, but this is in your user space, as you can see. Maybe you can unmute yourself. I think.
Yeah, just a quick question. The main thing is this takes up space and takes time to reinstall, which is fine, I guess. We just say that space is okay, but if lots of people want to do that, there's going to be a lot of wasted space, just like with sometimes with Python environments. What if we just want to add a few packages that for whatever reason didn't make it into E4S on top of the existing E4S ones? Is there a way to do an overlay, essentially? Keep the stuff that's in the standard environment, and then in our own location, just add extra things. And then with Spac find, be able to see both.
Yeah, so I think I think that's doable. When you want to install, I think do it in your shared project space. So that would be like your community file system. So depending, like, so if like you want to share the Spac stack with your colleagues under like CFS, there should be some kind of, like, let's say project, like some number. So I know I have one like M3503. You would just point all of your Spac configuration to, like, let's say the CFS or something like that, and then all of your colleagues will have access to it.
Okay, but I still would have to reinstall everything in that space. There is no way, as I said, to do just an overlay. So keep what you have in the central space and then just add only the extra packages that were not part of E4S, or maybe they were part of E4S, but with slightly different options as extra packages.
Yeah, I mean, you would have to do that in separate space because like these ones are like the production ones. So like they're not going to change. If there are any additional tweaks like variant, then yeah, you would do that. I don't think it would take up that much space, at least to be honest. Like I think the installing from the build cache, most of these packages would be trivial. It may take up a lot of metadata though, because there's a lot of files that get in, but in terms of storage, like, I don't think it's that much.
Somebody's mentioning something about chaining, so maybe that's the right terminology, but
yeah,
basically the idea was not to be replicating, was sort of just doing small additions on the existing thing without having to replicate anything that I'm building upon. That's the thing. So I guess I have to read about chaining.
yeah. Okay, so the next thing I will like to actually cover is our documentation that we have for Spac GitLab pipeline. And so this is under E4S, and the idea is we actually use Spac with our GitLab server, that's software.nersc.gov, to actually build pipelines using Spac. So there are a few use cases that you can think about. One is actually building your pipeline based on Spac at develop, so the development branch of Spac. This ensures that your Spac package work with the latest Spac code base, right? The other is using Spac at a specific branch to build a pipeline. So it's like, for instance, like the E4S branches, when E4S team cuts a release, they use a branch in Spac, so E4S 2105. You can also do that too. The other is, build, your Spac like unconstrained to a version or fixed to a version, or even build it at let's say at develop. So let's say HDF5 or fixed to a version, or let's say HDF5 at develop. And you may want to try different compilers. The goal of this would be, well, one is make sure that your product gets actually built and tested mostly built at the facility before you cut a release. Let's say HDF5 team cuts a release to the next version. It is working on Cori. That way, if there are issues, it would be addressed before they cut a release, and then that's a release of E4S. So we want to be able to use it to cut down the build time and all the issues that we may face like 2-3 months later. So for this, we have a few pipelines that we have example documentation. We'll go briefly over just one of them. And I would recommend, if you're starting out, you start out with the first one, which is the Spac nightly build. And if you understand this, then you can use this one. And then afterwards, if you want to actually go more advanced, I would recommend you go to the Spac Ci pipeline. So let's actually go to that, I think I have that up right here. Which one is this? Yeah. Okay, so the way that you would want to start out first is you create a GitLab project. The things that you would need is a GitLab Ci.yaml and some Spec.yaml to install the packages. The way this is going to work is we're going to do an HDF5 build with GCC 930 fixed to a Spac release of 2105. Okay, so this is going to be the use case of building at a fixed version. We're not doing Spac at develop this one. So the way, let me see if I can share. So the way this is set up is we have a Spac.yaml that will be used to push to the build cache in this location on a nightly base, and then we have a GitLab CI file. Let me open it up here. Actually, give me a second. Let me open it up and I'll make it like this so that you can follow along with the documentation. Okay. Okay. So I recommend if you you need to have at least some experience with using GitLab. There is documentation on GitLab CI reference. So I think there's a link to this at the bottom. Yeah, this link right here, which talks about the GitLab CI. So the first thing that you need to do is so one thing I need to mention is all of your GitLab jobs go through a Slurm job. So there is a key argument called scheduler_parameters, which you have to define in order for your jobs to be running properly. And this actually just maps to the SBatch argument. So depending on whatever queue you want to run, you would specify it here. So what we're doing is we're using one node with 4 processes and using the compile queue and just running them. We define we define a mirror. So that's this location right here, the repo and the branch that we're going to clone. And then for building the job, what every job needs to be tied to a stage. So we have 2 stages, build and install. And this is the name of the job. Every job needs to have a tags, which is associated to a runner. So if you want to if you want to run jobs on Cori, you would just use the Cori tag. And the way this pipeline is set up is it will do a build and install and push to the build cache, which is this script section, which you define whatever you need to do. And yeah, so but the pipeline, what it's doing is actually doing a full rebuild from source. So the trick is when we install, the specs get pushed to a build cache, which is this mirror right here. So we remove the mirror before we run the pipeline, because you can run the pipeline multiple times. The next is we clone Spac. There is a script that we have that just clones it in a unique directory, Spac clone path, and then source a setup script, and then remove this Spac user space environment. I highly encourage when you're setting up a pipeline, you do this, because that will avoid any configuration issues that you may get from your user space. We talked about the Spac GNU PG home. We need to set this in order to you know, get your GPG key set up. We create an environment from the Spac.yaml, activate, concretize, and then create the build cache. Yeah, let me see. So one of the things that is important when you're thinking about developing the pipeline is how you want the pipeline to run. I'm on the left right here. There is a section right here about rules. In GitLab pipeline, you can have different rules for how the pipeline is run. One is there's this variable called CI pipeline source, which tells you the event used to trigger the pipeline. A push means a push to the project will automatically run the pipeline. We have set up pipeline to run based on schedule and also the web interface. So what that means is if you go to the pipeline and you look at it, you would see pipeline that's scheduled by triggered by a schedule will show up here. And let's maybe just take a look. Required in order to set up a nightly build. We have a scheduled pipeline on a daily basis. So I'm just doing some troubleshooting here. If you take a look at your CI underscore variables, you have a bunch of variables that get set up. And one of the variable will be source. So this is schedule pipeline, okay? Another way you can run your pipeline is through the web interface, and we have set this up. If you go to pipeline and you click run pipeline and you do this, what this is the web interface of the pipeline. So this job will take some time. The reason why we have set this up over here on the web is imagine your pipeline doesn't run because either the GitLab server is down or there was some issue with Corey, maybe there was a system outage. You can still run the pipeline through the web interface without having to commit anything and without having to wait on a scheduled pipeline, okay? A push means that you have to push to the repository. So if you push any changes, then you would have the pipeline be triggered. The changes is a keyword in GitLab that tells you if you want to control which files, an event when the pipeline is triggered based on file changes. So imagine you're writing like you're updating some files unrelated to Spac or GitLab, and the pipeline triggers, and it's going to take up core hours. So one way you can actually cut down on this is the changes property. So we said if there are changes to GitLab Ci or Spac.yaml only, then run the pipeline. So that's a pretty useful thing. The interruptible equals true is something that will avoid running redundant pipelines. So imagine what redundant means is if I run a pipeline through the, let's say through this one right now, through the web interface, but I run another pipeline, it will automatically cancel this. So if you take a look at this pipeline, CI pipeline source, you see this is set to the web interface, right? If I were to run it again, the interruptible equals true will mean that after some time that previous pipeline will get automatically canceled. And this could be very useful if you want to cut down on core hours. Because every job, if you take a look at this job, it's actually going to do a slurm allocation on a node right here. and it would charge to your account. Okay. So let me go back. Yeah. I'll just briefly talk about this. Where is it? It's the Gitlab Ci. Yeah. So at the end of the install, another probably useful thing is you can parallelize your installs. So you can do something like srun and to do parallel build because you're in a Slurm allocation. So I think that support is pretty easy to do. In order to actually create your specs into the build cache, you have to do something like Spac build cache create and update index. What this means is that Spac will create, there's an index.json file that Spac has. Let me actually talk about this. So where is this? So if I navigate to this directory, oh yeah, because right now the pipeline's being created. So it won't have it right now. Right now the directory is not created because we're removing the pipeline. So once the pipeline runs, it will show it. At the end, what will happen is you'll see, you would see the specs in the build cache, and then you will install. So let's actually just go over this nightly build. Maybe I can go and show a previous run. So the nightly build right here, if you take a look, yeah, so we clone Spac, we set up a Spac root. So one thing to that we did is we're cloning Spac in our, like, let's say scratch space or something like that. The reason why we do this is we have to install with padding. So a lower, like a shorter length in the directory space really helps. And then, yeah, we just have unique directory names. That's a script that we have. And then we just install. So this is actually doing a full install of HDF5. Once it's done, we create the GPG key. The build cache and update index, and then we see all the specs in the build cache. If you take a look in our artifact, we actually store the spac.lock. So the artifacts can actually be browsed through this interface, and you see the spac.lock. This lock file is the one that was used to install this environment. And what we do after this is we actually use a lock file to install from the lock file. So the way that works is in our second job, we set up our Spac environment through this lock file. We create the environment, the mirror, and then install, and you would see the install is actually going to do it from the GPG key. You can see all the packages that were installed, and then we actually then just run the packages, Spac test run. And it's just running the test. So that is just a brief summary of this pipeline. So if I go to this, that's what this install stage is doing. And yeah, it's pretty simple. I mean, there isn't a correct way of doing this. I mean, whatever works for you, like your use case should be sufficient. For spac.yaml, just some things to point out. When you're installing from a build cache, you have to do something like a padded length, and some and the Spac install will be in the root of wherever Spac is, because you want to push it to a build cache and then at some point be able to reinstall or whatever. And you will be doing this repeatedly, right? So yeah, that's basically this. Some things that I would that I just found as I build the pipeline that you want to consider. If you're going to share the build cache, you want to make sure the root of wherever you host your mirror, which is whatever this path is read and is readable, meaning read and execute by all others. If you don't want to do that, you don't have to worry about it. When you create the build cache, there will be this file index.json. You want to make sure that it's readable. If it's not, then only you and maybe the group may be able to see it. The same thing with the .spac files. That's the specs that get pushed in the build cache. So there is a location where all of these are. You want to make sure that they're readable. The other thing that we found is that 127 for the padded length seems to work pretty well for us. If you're going to use CFS or Scratch, that seems to be fine. If you're using the CI projector, which is where typically the installs are actually happening, you're going to run into padding issues. Okay. Another thing that you want to be familiar with is that you want to set your GitLab job timeout to something higher. That way your job doesn't get terminated. And the schedule pipeline that we have set up, it's pretty easy to do. You go into CI/CD schedule and you set up a pipeline, just new schedule. You can edit and customize the interval if you want. So that's all that you have to do to get this to trigger nightly. And yeah, I want to briefly, I'm going to be wrapping up pretty soon, but I have one example that I want to show you. If you're interested in how Spac CI pipeline works, this is another pipeline that uses the same example that I showed previously, but using a slightly different version branch, E4S 2108. We're going to be building HDF5. The thing that we're doing with this is we have a Spac CI command to generate the pipeline. And what that means is, if you take a look at the pipeline, in Spac, we use a generate job with build, and there's child jobs that are actually doing a multi-stage build of each of these specs. And each of them are being installed parallel. So that's kind of cool. If you take a look at like Zlib right here, this one is being installed in its own Slurm job. And yeah, and the way the Spac CI rebuild works is, Spac CI works is there is there is a what is it called? A GitLab CI section that you have to specify in your spec.yaml. And this is what it looks like on our side in order to install. And it's a two-stage process. So the GitLab CI has a Spac CI generate, and it generates this pipeline which you store into an artifact. And then there's a build job that actually takes that pipeline and it does all the work. One thing that I just want to briefly show is this pipeline, when it runs, it actually pushes all the data to CDash. So it's pretty easy to do. If you want to set it up to push data, you can just copy this kind of section in your spec.yaml. And if you take a look at CDash right now, these builds actually get pushed to a build group. I think, what is it called? DOE nightly E4S builds. Yeah, right here. So you're seeing live kind of builds for the pipeline that I just showed you with like builds of each of these. This is the name of the site that you define over here. And the URL in this project are just going to be those, at least for the time being. And then you can actually see the actual builds, like here is a CMake build. Yeah, I think that's all there is. I do want to encourage you, if you want to set up pipelines, that that you go and take a look at other examples. We have a pipeline here with other projects. There's a dashboard which shows you all the projects that have pipelines, and I think, yeah, you could take a look at the HDF5 and TAL. They're pretty good examples. That's all that I have. I'll open it up for any questions. I see that there is a question by Brian. Yeah, you can have you can assign a different user. Probably a collaboration account would be the way to go. You would have to create a collaboration account. There is some documentation on that under accounts, collaboration account. That account would be something that you would create based on your project, associated to a project name. Actually, in fact, we do this. This username that I have, E4S, is actually a collaboration account, so that we can actually run jobs through this user, as opposed to using our own usernames. Any other questions? If I don't hear any questions, then I think we can have our break, and then we'll proceed next with Ryan.
Shazib, this is going to be a 10-minute break.
Yeah, I think we can give 10 minutes. I think it should be okay.
So then we'll be back at 10:40 here in California.
All right. Well, thanks, everyone. Hopefully you had a good break. Come back refreshed after grabbing some caffeine, coffee, something like that. So Shazib asked me to give an overview of software deployment at facilities, which is the area of ECP that contains both, Shazib's software integration team, as well as continuous integration and some vendor system testing. We work very closely with the software technologies area of ECP. And really our mission is to take the software technology tools, so like programming models and runtimes, development tools, math libraries, data and viz, and the software ecosystem and delivery work that's coming out of the Exascale Computing Project, and sort of map it to the facilities. And so the first couple of years of work with ECP, we were working on helping Mike and ST and Samir Shendi develop what a real software portfolio would look like, right? How does it, if we create this software stack, how can we deploy it to facilities in a way that meets everyone's needs? And so as we were discussing these things a couple of years ago, it really did seem like Spac was the right tool for the job. And that's kind of why we're organizing around that, and we're using Gitlab Ci as well for the automation of a lot of these pieces. And so Mike, gave an overview of ST and E4S, and Shazib went very tactical, especially at NERSC with how a lot of our software deployment has been done there, right? And how to load modules and get access to the facility installs. And so I wanted to kind of back up a little bit and sort of maybe hit the middle between the two, right? So how do we take that software ecosystem and think about the ways in which we deploy it and the strategy there. And so our area, software deployment, really has three, I guess, main focuses, right? So Gitlab leads the facility, E4S deployment pieces of that, especially at NERSC. He's done some really awesome things and has documented a lot of that, as you've seen. Another major piece of our area is to maintain continuous integration. So that's GitLab. And I think of that as providing a platform for automating the building and the testing that all facets of ECP and also the facilities can take advantage of to just provide software assurance, right? That what we're installing makes sense. And then the smaller piece that I won't touch on too much today is again, evaluating vendor system software. I want to call out though that.
Hey, Ryan, I think your slide hadn't changed.
My slides haven't changed. Oh no.
Yeah.
You see this okay? Should be on slide 3. Let me see if this is.
Yeah, I think you were presenting 4, right?
Yeah.
Yeah, we were seeing this slide.
Were you seeing this slide here?
Yeah.
Okay, let me see. I'm going to move forward one slide really quickly. Can you see the new one?
Yes.
Okay, sounds good. And one thing I wanted to call out here is that each software team that you see in the overall Exascale Computing Project and each of the facilities, like NERSC included, have individual and very unique strategies. And so it's been really, I guess, enlightening and eye-opening coming together and developing this portfolio really that uses E4S sort of as the linchpin. So I'll talk about sort of like how we're structured. So the software deployment facilities area has these 4 main focus areas. There's building and testing and deploying products. There's the ECP CI infrastructure, and there's 2 testing sort of slingshot and Shasta testing areas. And so Gitlab leads the software integration piece. Paul Bryant at ORNL leads continuous integration. Jay Srinivasan at NERSC leads the Shasta testing piece, and then Scott Ashley at ORNL leads the HPCM and Slingshot, which is sort of like the alternative to Shasta that we were exploring the risk of last year. And when you put all these things together with the rest of the ECP software portfolio, I like to think about these things as layers of a cake in some sense. So on the right-hand side, you really have the AD applications and ST tools and libraries up at the top, and that's primarily what ECP is driving forward. And then Samir and Mike Haru and Todd Gablin are leading this E4S and Spac. It's really a middle layer that helps those teams map their products to a place that is tested and is installable for Gitlab software integration team. And under that, we have the continuous integration infrastructure, which automates everything above. And then our facility hardware testing at the bottom. We also created this task force called the Testing Task Force last year to really be deliberate about how we integrate testing into the ecosystem, right? It's not just software development. It's not just build tests. It's more than that. And we want to make sure we're being very deliberate about how we do that across ECP. So I'll touch first on software integration, and then I'll follow up with continuous integration. So this is Gitlab's team, and this is across the ALCF, OLCF, and NERSC facilities. So Frank Wilmore, and he's on the call too if you have any questions for him, is the primary software integrator at the ALCF for ECP. Aditya and Shazeb helped, this past year, they both were on this effort from the NERSC side of things, but Aditya did leave recently, so we're looking for a replacement there. And then Matt Bellhorn and Jamie Fenney are the ones leading the software integration effort on the OLCF side, with Shazeb kind of helping manage all of the reporting up and down from ECP. And so what you'll see if you look at the ALCF and OLCF facility sites is, as systems get closer to delivery, when the TDSs arrive and the the early access hardware arrives, right, more and more concrete deployments of E4S will be delivered, especially those that actually use the accelerators or the vendor compilers and things like that. Originally, at the beginning of last year, we did deploy E4S using GCC and sort of older style, older generation tuning, right? But we really want to get these ST products adapted for the Exascale platforms. It's really what ECP is here for. And so if you take a step back, and this is a slide that is very busy, but it's sort of, I feel like it's the least complicated it can be for the complexity that we have really in the E4S software environment. You kind of see the flow of development that happens, both at scientific institutions, the testing happens at facilities on the left-hand side, up through Spac, which is really the centralized, build nexus, right? Spec recipes are created for all of these products. E4S then plays this role of a curator, right, across all of the ECP software that's part of E4S, and then the facility teams take that E4S release, like 2105, and our Shazeb software integration team deploys that at the facilities for users to use. And so I think it's useful to know that we have this continuous integration capability using GitLab at each of the facilities, and it's integrated with the scheduler. We've had to go through quite a few security reviews, right? What we don't want is every single user to have their own GitLab runner. You would like to have one runner that multiple projects can use to reduce complexity and to be able to submit jobs to the batch schedulers and things. And so pretty early on, we developed that capability. And those platforms now are available to software development teams, as well as end users and as well as facility integrators at the platforms. And so that platform is, we encourage software teams in the ST area of ECP to use it, but we also understand that these ST teams have a lot of other build and testing pipelines that they may have. There might be a very well-defined Travis CI infrastructure, or they may have Jenkins set up at a couple of different home facilities or other labs, and they may have developer unit testing that happens. And so really it's a combination of all of these tests across the portfolio that contribute to software assurance. But at the end of the day, when an ST team or an AD team is ready for their product to be packaged up into Spac, they go and they create the right build recipe for themselves to get thrown into the Spac develop branch. Spac and the E4S team do their own, of course, build testing, smoke testing. A lot of that is done either in AWS or Livermore or on Frank at the University of Oregon. And then assuming that everything passes, that sort of gets pushed forward through the Spac develop branch. And then periodically, once a quarter or so, the E4S team that's led by Samir really helps curate and cuts releases of these E4S products. And they'll provide like a recommended set of versions of software that have been tested and that are recommended for facilities that our team will pick up and deploy. And those are deployed on the right-hand side of this diagram here to ALCF, NERSC, OLCF using Spac, made available through build caches and through environment modules and things like that. And of course, you can append to those or add on to those stacks if you would like. And the facilities are making their build environment and build sort of spec available if you'd like to start from there. So we sort of have this consistent story across all three facilities that are on the Office of Science side. And we're providing GitLab as a platform for automating these tests and builds. We're encouraging teams to use them as appropriate, using the facility resources that they get allocated. E4S is helping us curate this, and then the software and deployment teams are doing that, deployment to the facilities. And so, I step back and I think about the different roles because the ECP software ecosystem is so large. You have to have roles and you have to have delineations of responsibility in order to really, map scope, right? And so again, on the left-hand side, we have ST development, and they're doing development with best practices in mind. And I think Mike talked about this a little bit earlier, but there are E4S community policies that to be a member of E4S, a member package, a team signs up to commit to a certain level of service, having buildable software, having some unit testing involved, and good documentation. And so that's really defined, in that link. And these teams are also taking advantage of the ECP, ideas work, where productivity and the best scientific software practices are really being made available for these teams to help, deploy or build scientific software, but in a best practices sort of way. And again, in the middle of that diagram before, we have the E4S software curators, and I consider the Spac team to be part of this, since E4S is really built on top of Spac. And they, of course, have their Spac GitHub repository and C- that Shazeb was showing just a few minutes ago, where you can see, builds and if they're passing or failing from different GitLab pipelines that are set up across facilities, as well as the E4S team, right, which is preparing quarterly releases. And so an example is 21.05, which you can go to this GitHub link to take a look at. 21.08 is also out, and our facility staff or software integration team are building this and deploying it right now and testing it and working out issues. And then on the right hand side, the SI team is deploying these things. Shazeb showed this the 21.05 release, and facility teams also on the user assistance, user support, and systems administration side also have their own validation testing and test harnesses that they run on this installed software. And so altogether, it's a really, I think, comprehensive, many different roles, but comprehensive environment to provide assurance to the parties that need it. And so I was stepping back a couple of weeks ago, just thinking about the different layers that we have of testing. And I think we have 6 layers really of testing, but there are sort of 5 different types of tests that I think are happening pretty regularly. You all are probably familiar with this, but there are build tests and there are validation tests. And I like to think of the complexity of these as being pretty low, smoke tests for validation to make sure that the libraries exist that they're linked against and that they can run a hello world, very simple kind of hello GPU world test, as well as builds. Does it build? That's something that's pretty simple. And that's contrasted with integration tests, which are a little more heavyweight, where you have to have other tools built that are related to it and that are linked to it to really do integration tests, and then regression and performance tests, which can be more costly with CPU cycles, GPU cycles, and time on the machine. And so there's this, which I'll talk about in a little bit, this value per cycle proposition, right, that we want to hit, because it may be that a lot of the performance and regression testing can be done either on local workstations or on local institutional clusters or in the cloud. But the really big runs that are super important have to be done at the facility. And so there's this value per cycle trade-off that the teams are very aware of. But in general, the ST teams are really implementing all these test types on their own work that they do as they're working towards development. And they run specific high-value tests of all types on facility CI platforms. Then the Spac team, right, tests builds in the cloud and at some facilities. The E4S team does build validation integration tests. The SI teams run build validation integration tests on facility systems, and then the facility users themselves, like you, right, can run validation tests such as Spac test and even the E4S test suite on the facility installed software. So we have a very comprehensive testing framework, and that's exactly what we were setting out to do at the beginning of this project. In terms of where we are and what we've been working on in the last couple of months, Shazeb's been leading an effort to sort of collect a lot of this documentation into one place. It was sort of scattered across ECP specific Confluence pages and things. And I think he and the E4S team have done a great job to sort of centralize a lot of this information that you, the end users, can get at. So end user documentation exists and it's out there. The product dictionary now has lists of E4S products and CI badges, as well as the various Spac packages that are part of an E4S product. That sometimes they're not named exactly the same thing, and so mapping is important. The E4S facility dashboard outlines the deployments that exist, and so you can see there's some at NERSC, at ORL and ANL, and along with how many packages are installed and the compilers that are used for those packages. And of course, there's the doc portal that Mike and Samir have been working very hard to get up. And that's been up for some time now, but it keeps getting new features added to it, and is a very good resource for anyone interested in getting documentation about one of these products from the ST team themselves. And of course, there's this E4S nightly build pipeline that Gitlab is working very hard to create and maintain. And so he has a couple of really important, I guess, crucial pipelines that are running, and he's been asking the software teams themselves to help maintain these pipelines to show that individual build tests do work regularly on Cori. And so there's some documentation on that is out there at the NERSC site. And then finally we've got the C4S 2105 module file on Cori, which Gitlab was demonstrating earlier. You can of course go and learn more about that. There's a lot of resources online, and if you want to see how, in some sense, the sausage is made during ECP software deployment of one of these releases, we do track issues at gitlab.com ECP SWD repository. So we do track issues just like other software teams track software issues, and it's helped us out a lot to use the same tools that developers are using to deploy software. It's good to use the same ecosystem, I guess I would say. And so, Gitlab showed off this a little bit, the deployment on Cori. These are discoverable, with Spac find. So I guess, are there any questions about software integration before I move on to our automated continuous integration platform? I don't know if I can see the chat. All right, well, I'll move on. If you have any questions, feel free to plop them in the chat, and I can address them. So software integration, right, is about taking this ECP software stack and getting it to supercomputers in a very well tested way, or as well as we can test kind of way where it makes sense. Continuous integration is about automating these tests. And so I like to think about CI as really having three main use cases, okay? For ECP and for scientific computing. One is the one that, the first one is the one that most people think of when they think of continuous integration. And this is regression and performance testing, where as you're a developer, you're making changes to the code, and if you can detect software failures right away, it saves a lot of time, and you don't introduce bugs that you didn't mean to introduce. Bugs and performance regressions and wrong answers, right? Those are all really bad. And so I guess I want to say on the left-hand side of this diagram that a lot of that work can be performed in the cloud or on developer workstations or other CI pipelines that might already exist for that particular product. On the right-hand side of this diagram, more of that work has to be done at the HPC facilities themselves because it's tied to the hardware or it's tied to the vendor-supplied compilers, and software environment, which sometimes, right, because of NDAs, can't really be packaged up and ported out to more open areas. And so then again, in the middle section here, right, we have ecosystem integration. This is where the integration tests really are important. And I also would say that a lot of these can be performed on many different platforms that aren't supercomputing specific. So, E4S has quite a lot invested into container deployments, right, of E4S. If you can package up the software stack in a container and ship that around, that's pre-built, that's awesome, right? And so that container, right, can be tested on a lot of different environments. But HPC containerization, right, still has some thorns. And so, when you jump over to the facility operations assurance side, I'm sorry, was there a question? Okay. When you jump onto the facility operations assurance side, especially where your installed software stacks may not be changing if a new release of E4S hasn't come out, but your compilers or your communications libraries or vendor supplied software has changed after a downtime and a reboot. This environment drift can be detected, right, by having good continuous integration practices of a V&V suite. And so this is one of those things where you do need to do this work on a HPC system. And so it just makes sense to understand the value per cycle trade-off as we're trying to target the right place to run our testing. Across these three facilities, we do have runners and GitLab servers in place for software teams to use. These, the GitLab job, the jobs that runners kick off, the GitLab runners kick off, typically run either as a project user, a shared project user, or as the user of the runner that's running, and it sort of changes to be you when you run it. And that's so that we don't have, again, a million runners. If everybody set up their own runner, that would be sort of hard to manage and understand. But that being said, the allocation is typically based on your project's allocation. So make sure that if you're setting up very robust CI pipelines, that you're not eating into your scientific allocation on a resource. But that being said, each facility has their own set of set of GitLab licensing that they've chosen to buy into. So some features may be in some facilities and not others. So just work with the site CI coordinator for ECP at that facility if you're having issues. And then finally, I wanted to go over sort of like a typical month. And this was data taken from April and May of this year, sort of a couple quarters ago, across the 3 Office of Science facilities. So NERSC has quite a bit more active projects than ALCF or OLCF, which I think makes sense. But typically the average job times are, for some jobs that are really running smoke tests, are like 1, 2, 3 minutes are typical. To more of the build tests that are a little bit longer in the tooth can be up to 2 hours. And sometimes these jobs do run up against Q policy limits, and so we recommend that the facilities be aware of how their CI platforms are being used to make well-informed decisions about Q policies for these types of continuous integration automation jobs. In general, jobs are executing all the time, which is really great to see. And depending on the facility and amount of hours that are allowed to be spent and the size of the resource that are attached to these runners, you can have any from 1,500 hours to NERSC had quite a few more over that month. In general, the number of tickets or so per week that our continuous integration coordinators have been getting are very manageable. A handful a week. They're pretty easy to help users set up new projects, that kind of thing. NERSC has a couple of special Q policies, whereas ALCF and OLCF don't. But all the 3 facilities say that the resources right now, at least dedicated to this sort of CI, are adequate. And so in general, that may change as we move forward. And if you're working on speccing out a new system, it makes sense to leave some headroom for automation for users. And so if you all are interested in automating your software testing and things like that, make it known that you'd like some cycles for that, because you do have to build in this sort of capacity at the when you procure a system, or even when you're in the RFP stage, very early on, as part of the science use case gathering step of a new system.
Hey, Ryan, can I ask you a question?
Yes.
So going back to slide 17, I was noticing that so some of the systems are production systems where others are, more on the experimental side. Is there a rhyme or reason as to which systems have this capability deployed and which systems will have this capability deployed?
Yes. At the very beginning of the project, the rhyme was, where can we get this to stick so we can start prototyping it? And if it's been useful, we've kept it there. So on Ascent, which is an OLCF, it's the open summit in some sense. And at the JLSC, at the ALCF, and on Cori, on NERSC, those were 3 systems that were pretty easy to get the platform deployed on. And so that's really where we started. As we move forward, we're focusing on getting the GitLab capabilities deployed to all of the systems that ECP users will have access to. So this will include the Aurora and Frontier ecosystem systems, as well as Perlmutter when it's up and running.
Great. And so Helen has another question she asked in the chat was, will the stack, well, I guess in general, E4S stack and maybe even some of the server capabilities be available on Livermore, Lano, and Sandia systems?
So I know that our continuous integration effort has, we've been coordinating with Thomas Mendoza from, I believe he's from Livermore. I might need help on that. And so I believe that a lot of the GitLab capabilities are going to be there. I don't know exactly if or how, E4S will be made available from a, like a systems and software integration perspective. Certainly, if a user, if you can run Spac there, you can build E4S. I would wager, but I would have to get back to you on that, about how that will work on the NNSA side of the house.
Okay, thanks.
That's a great question, though. So, and then just to round out, I think Mike had this slide earlier as well. We're really trying to leverage this turnkey stack, right? This is a new way of packaging up the scientific software portfolio. So it's hopefully less cat herding in the future and more, well-defined, agreed upon standards that we can use as interfaces as you go from software building to software integration and curation to software deployment, and sort of have a very holistic testing a framework across all three pieces. So, and with that, I think I am done. Are there any further questions? All right. Thanks, everyone.
Hi, I'll cover the remaining slides on the components of E4S, the container aspect of E4S, and take any questions. I have posted my slides in the chat window. I hope you can all access them. So we all know about the growing complexity of scientific application software stacks. And as our software gets more complex, it's getting harder and harder to install tools and libraries correctly in an integrated and interoperable software stack. You can see here the ECP applications that are primary consumers of ST products and which products are very relevant over here. And you can see in the case of Nalu, this is just a graph of the dependencies. The graph is getting more and more complex. That was Nalu, this is deal 2, and here is R minor. So getting all the components installed in a manner that allows the applications to run correctly is a challenging proposition at times. And even proprietary codes are not immune to this. They often depend on many open source libraries. You can see that in this graph, the blue nodes are all open source packages. So ECP is, as you know, putting together an entire ecosystem of applications, software packages on different architectures, compilers, programming models with different versions. And that can lead to a combinatorial explosion of all the packages. And we are at a stage where developers, users, and facilities are dedicating many FTEs just for building and porting the applications. And many times we notice that they often trade reuse and usability for performance. So typically, the traditional approach of installing software on a supercomputer has been to download all the packages one by one and start building the tools by using, configure, make, fighting with the compiler, tweaking configure flags, installing, And then finally, when you get the binary and you run it, if it gets a seg fault, you start all over again. And modules don't solve that problem because modules just set paths to packages that someone else has installed. So with this, we talk about Spac. The E4S uses Spac package manager for the software delivery. And Spac provides the ability to specify versions of software packages. And Spac is a build layer for not only E4S software, but also for a large collection of software tools and libraries outside of ECPST. And it's the core platform that E4S uses. So to use Spac, you can just do a git clone on the repo, just source the setup environment. And this is important, as you will see, even in the case of deploying our packages using Spac within a container. And how do you install a package? You can just say Spac install the spec. Here, Spac install tau will install the tau performance system and all its dependencies. After sourcing the setup.env.sh, I typically use Spac compiler find so that my compilers are then recognized, and then Spac external find so that the external packages like M4, AC local, tar, and all, so that all of these packages don't need to be rebuilt from source code. And then you can specify, say, Spac install tau or tau version 2.30.1 for a custom version. Or you can say with compiler version GCC 9.3.0, where @ is the symbol for the custom version, percentage is the symbol to specify the compiler name. And this is the compiler name that it recognizes in the Spac compiler find. And then you can specify options. You can specify variants. Here I'm saying, please use the level 0 interface in tau for Intel GPUs and specify other options like OpenMPI or OpenCF. You can specify MPI, you can specify MVAPH2 and version of that with specific variants for that. Like here, I'm saying don't use the wrapper RPath argument. Once it's installed, you can say Spac find, and then you can see all the packages. And multiple versions can coexist. You can just say Spac load with a -- first to specify a given package. And you can learn more about Spac from this spac.io webpage. The components of E4S are a curated Spac-based software distribution. And Spac build caches, binary build caches for bare metal installs or containers for multiple platforms, including x86-64, PPC-64LE, and we are targeting AArch64 in FY22. We want to support container images on Docker Hub as well as E4S website of pre-built ECPST products. We have both base images and full-featured containers with GPU support. And I mean support for Intel, AMD, as well as NVIDIA GPUs. We have GitHub recipes for creating custom images from the base images. And there is GitLab integration for building E4S images. We also have a validation test suite to make sure that the packages that are installed correctly. And Spac also has a Spac test, smoke test, that helps with this validation process. We have also a tool called E4S CL, which is a container launch tool for substituting MPI within a container in applications that are built using E4S containers with MPICH ABI, and we have recently added support for OpenMPI as well. And we have VirtualBox image where you can learn more about the container runtimes. You can just download an image and see the use of Docker, Singularity, Shifter, and Charlie Cloud. Since this is a presentation for NERSC, I will focus more on Shifter in our container components. We also have images on AWS that you can deploy. So as Mike mentioned, we have had a series of releases, and we are doing this in an aggressive schedule of every quarter we have a new release. So you can see that we have a release from the latest release is 2108, which has 88 full release products. And we support both HPC and AIML products that are difficult to build. So with containers, you can get a full set of packages pre-installed. Containers are a lightweight collection of executable software that encapsulates everything needed to run a single specific task. The key thing to remember with containers is that it does not include the operating system kernel. It's based on Linux, and a container is based on a given operating system, but without the kernel. It uses the kernel of the host. You can think of it as chroot on steroids. And Docker is the most commonly available tool, but it's not very suitable for HPC platforms. Now you can see over here the key distinction between hypervisors and containers, where with a hypervisor you can have virtual machines running their applications, and there is an operating system over here. And you can also run a hypervisor on top of an operating system where you have an entire operating system here and another one here. But with containers, you have the host operating system on top of the hardware and different container packages. And there is no kernel or another operating system over here. And that's the key difference that you get with the efficiency of using containers. Now we support Docker, and with Docker, you already have support for other runtimes, but there's a Singularity download, there's a Docker download on the E4S download page. And you can even pull the images using this Docker pull ECP E4S command like this. We also have GPU images, a multiple architecture image for x86-64 and PPC64LE. And we also have continuous integration images and base images that you can use to then create your own custom images. And there are some examples of that here. And then there are some facility deployment pages here. So if you download the container image, what do you get? Well, with the 21.08 release of E4S, there are 88 official products and dependencies. And I'm not listing all the packages here, just the main ones. This is for x86-64 using GCC. And we also have support for GPUs. And in this one image, we have NVHPC 21.7, we have CUDA 11.4, one API, and ROCm for AMD. So we have support for all 3 GPU runtimes. Here are some of the packages that you can see. This is 1 through 44, and the exact location where they are installed within this image. This is 45 through 88 of these packages. So you'll notice some packages like say PETC or Strumpack or Sundials or SuperLU or Tau or Trilinos. They are all pre-installed in these directories. Here is the set of packages using the DOE fork of LLVM, Clang 13. And you'll see these 34 packages here and going all the way to 68. So we have 68 packages that we have been able to compile with the DOE fork of LLVM. We are trying hard to reach higher numbers over here. And this is on IBM Power 9 PPC64LE with GCC. You see the 1 through 44 packages here. We have support for CUDA 11.4.0. We have support for NVHPC 21.7, which are these runtimes are bundled as part of the container that you can download and use with Singularity or Shifter. You have these 45 through 88 packages. So there are 88 official products for GCC with PPC64LE. And these are the ones with LLVM compilers. So you can see over here, we have about 52 products that we are able to build with PPC64LE with LLVM. And there's a MPage there which uses LLVM compilers internally. Now, if you want to use containers, and Shazeb covered how we can use the bare metal installed versions where we have support for the MPI and Intel compilers on Cori. Well, Cori also has Shifter, and Shifter is a very mature HPC runtime for containers. And if you say shifter img command and look at the images and grab for E4S, you'll be able to see which versions of E4S are available there. We have an image of 2108. He showed in the slides how 2105 is deployed with bare metal packages. And we also have 2108 available on Cori. And I'll have a small demo here to show you from using the E4S test suite. I have a full Trilinos application called Zoltan. And to launch shifter, I can specify the image. I can say run bash command and source the etc bash rc, and then Spac will be in my path. Then I can say Spac find and any of those commands that you saw earlier. You can then go to the Zoltan directory like this, and then run the compiler and compile the programs. You can see the MPI in your path and then exit. But what is interesting is if you want to use the system MPI, because you have a very high performance network interconnect between the nodes and you want to use the system MPI, shifter allows you to do that. You just have to make sure that you source the Spac setup scripts and then load the packages that you need while running the application. You unload the MPEG, you can use the system MPI with shifter using Zoltan like this. And I'll show you a demo of this right here. So here, if I say shifter and specify this image and say that please use the startup script of etc bash rc, I will then have access to all the packages. Now here, if you see etc OS release, you will see that this is the Ubuntu 18.05 release, 18.04 release of our container. I am within a container session here. I can see Spac. I can say Spac find. And I can see all these packages built using GCC within the container. And then I can see the packages built with Clang. The total of 811 packages here total. So with this, I can see various packages that are pre-installed. I see, say, Tasmanian, Tau, Trilinos, and here is the compile.sh script that I'll be using so that in this make file, I have this cxx main.cpp program that's using a number of libraries. So I can say compile.sh, and then it will build the application source code into the executable, and it will pick the Trilinos package, and you will see that it loads up a large number of libraries that are needed to compile the program. Now, here are the set of libraries that we are Trilinos libraries that we are using from within the container. And so with this 2108 release, I am able to build this application, Zoltan. And if I say Spac find, Spac load first, Trilinos %GCC. So I'm just saying, just pick a Trilinos, the first one, and just make sure that it's using the GCC compiler. Then I can do an LDD on Zoltan and then see which are the libraries it needs. So that's quite a few libraries that it loads. If I see how many, it's about 41 libraries that it loads, and it's using MPI from within the container. This is not the system Cray MPI yet. It's using the MPI from the from within the container. If you want to see which one it is, here is the libmpi.so, which comes from mpeg 342 from within the Spac installed container package. Now with this, I have the binary and I have built it. Now I can, of course, run it here on the login node, but I won't do that. I can of course run MPI run like this within the container, but it's not advisable. So I'll exit from the container. So now I'm back on the host And how do I see that? I can say, look at the OS release. I'm no longer in the Ubuntu 18.04. I'm in the SLES 15. So now, if I look at the run.job script, here what I do is I specify the image, and this is the key integration between Slurm and Shifter. So Slurm understands the shifter image semantic. So I'm saying, please load the 21.08 image of ECP E4S. And then I'm just setting some environment variables. I'm saying unset this, source the Spac, load the Trilinos module, and also unload the MPitch. I'm not going to use this MPitch that I had over here. I'm going to use the system MPI. I'm allocating 4 nodes, 4 full nodes, and I'm running the job over there. And I can say there are no output files here, sbatch and run.job. And with this, my job is submitted, and it will run on these nodes 2300 to 2303 using the fast interconnect between the nodes. There are 4 nodes allocated for this job, and it's still running. And maybe it's there. I can see the output file, and let me look at the partial results from running this. And there it is. So this is the Zoltan solver. And you can see this is it's using Parmetis, it's using those 41 libraries running on 4 different nodes using the system MPI, not the MPI bundled inside the container, but the system MPI. And you can see that it runs these packages, iterations, and so on. And so you have an execution. Now you can also, if you were looking at the images, shifter, img, grep, ECP, E4S, shifter, img, images. To list the images, you'll see the different ECP, E4S images. I'm using the latest 21.08 image over here. We also have something in production for the next 21.11 release. And if I'm on, say, Perlmutter, and I tried that same thing over here, you'll see that even before we do the full deployment of our software stack, we having just one container that can be accessed through Shifter can help the developers get immediate access to a large collection of packages that are pre-installed within the container environment. You can just use a bash command and just get into the container. And what is important is that the compilers and the MPI is inside the container. Your application and data is outside the container. So with that, you can use that model for, here is a Perlmutter. And if I say shifter, img, images, then I have an image over here. And if I want to say, I can just load it, and then I will have various packages available to me. So here, now I am in the Ubuntu 18.04 image, and I can just say Spac find and see the different packages that are available, and then build based on that. So here is, for example, make clean. This is the NAS parallel benchmark, and I can build it with MPIF90 that comes from within the container, and so on. And here is the information about using shifter on Perlmutter with, okay, here is the build. Maybe the login node is a little overloaded right now, so I will not try using that. But you get the idea that with shifter, you can substitute the MPI, you can launch the packages, just that the commands are a little, you have to know what to do with the libraries and source the various packages like this. So so here are some examples of just using and loading packages with shifter. So you can download E4S from the E4S.io webpage. There are some notes over here if you want to build this on another system. We have instructions for bare metal installation. We even have a build cache. And with this release, there's a spac.yaml file which you can refer to. You can see the build cache in this 21.08. And you can add this mirror, the cache.e4s.io. So you don't need to build all the packages from the source code. You can use binaries that can be downloaded. We have over 50,000 binaries spanning a range of architectures and operating systems that you can find at this inventory.html page. And the build cache allows you to just download those binaries, provided you have the same architecture, operating system, compiler, and then the hashes will match if you are using that specific version of Spac and the build cache. And then you will not need to download the source code and build it. So that can cut down the time for installing your packages dramatically. So here is a spac.yaml file as an example. And these are Docker recipes that we have. If you were installing this on a bare metal system, you could just say spac-e dot install, and that with this dot current directory, it will look at the spac.yaml file in the current directory. But you can also create your own containers. And here is a command which shows you Docker build, where you can just say, even without the cache, you can give a tag like this, and then use the dot, and then it will build the packages using the Docker file that is there in this Docker recipe. And we have base container images for, in this case, we are showing Ubuntu UBI for Red Hat and CentOS for PPC64LE. They are available on Docker Hub. We have similar images for x86-64 and multi-platform Docker recipes that you can find here. And this is a typical Docker file which says that use this as a base image and then use this as the work directory, copy the spac.yaml file here, do a Spac install, and chain these commands so that you get a more optimized image where you don't run the commands with multiple run, but you chain them with the and operator, and then you specify the work directory, and you can create your own custom containers. Here are reproducible Docker recipes for x86-64, PPC64LE, and AArch64. And the VirtualBox image that I mentioned earlier, which has support for containers from Docker, Shifter, Singularity, and Charlie Cloud. You can see the different Spac-based builds over there in the VirtualBox image. So you could have this image for training purposes running on your laptop with VirtualBox. Or you can even run Docker or some of these other container runtimes on your local systems. We also have a tool called E4S CL. It's a tool to simplify the launch of MPI jobs. And it has a very simple syntax. It's based on our previous work on Tau Commander. And you can say E4S container launch initialize or init, and you can specify the backend, which specifies which container runtime to use. We have support for Singularity already, so you can specify backend as Singularity. You can specify the image as this SIMG image, and then source.sh or some source original startup scripts where you can specify how you initialize Spac and which packages to load when you run the application. And then with that, you can just say E4SCL with the MPI run and then give the application, and it will do the substitution of MPI itself. We also have support for a package called Y4MPI, which comes from CEA in France, which allows us to substitute not just MPitch, but also substitute an MPitch application with OpenMPI. And that is now available in our E4S AWS instance. If you are interested in learning more about the MPI substitution, please discuss with me offline, and we can tell you more about how this happens. This is the general launcher tool and how we can run the E4SCL with substituting the host libraries. We have to maintain an entire database of how the substitution, the list of libraries and how that substitution takes place. But we have working examples where we are able to substitute with Intel MPI, MVAPitch2, or OpenMPI and system libraries too. So we also have a big effort in continuous integration and testing. Here is the validation test suite that I mentioned earlier. And in fact, that Zoltan example that I showed comes from this validation test suite. You can have container builds using the base images. And this is the Docker file, and this is a spac.yaml file. This is for a custom image that we create for SuperLU. And here are some GitLab runner images. So you can pick different operating systems. So you don't have to just be on Ubuntu. You can choose a UBI system for, say, Red Hat 8.4 or compatible UBI version. And you can use CentOS, you can use Ubuntu for different architectures. Here are some GitLab pipelines that we have running for different operating systems at the University of Oregon. And at the University of Oregon, we have a collection of systems we call Frank, and we have support for many GPU architectures. In fact, within the cluster, we have all 3 GPUs, including A100 from NVIDIA, Intel DG1, and AMD GPUs. We have support for MI50 as well as MI100 GPUs. And I would like to thank AMD and some of the vendors for providing hardware for our Frank systems and supporting this project. And we have pipelines running, as Shazeb showed, on Cori, and GitLab pipelines running at Oak Ridge. This is on Ascent, which is the open summit system. And there are badges that Shazeb has created where some of the packages have CI badges associated with their achievements. So with this list of components, we come to the community engagement. And there are many opportunities to engage with the E4S team. And we would like to work with you and provide support for your packages, whether you're building an entire application or a single tool or a library. We can help with supporting your work with our E4S build caches. We can provide support for GPU runtimes. And then you can also use the GitLab facilities for continuous integration. And we would like to work with you to make sure that your applications are using the E4S built packages, that you can use the build cache to dramatically reduce the compilation compilation time and efficiently run the applications using bare metal E4S installs, as well as using containerized runtimes, and substitute MPI with the system MPI so that you can get very good performance for cross-node performance using the native MPI. So in summary, I would like to say that E4S is not a closed system that just takes contributions from DOE software development teams. You should rather think of E4S as an extensible open architecture software ecosystem that does take contributions from US and international teams, and a framework for collaboration, a framework for collaborative open source product development and integration for ECP and beyond that. And it has significant AI ML components, and we are looking at what we can do with quantum computing as well, and providing a consistent software stack. So E4S is not a monolithic take it or leave it software behemoth, but it's a full collection of compatible software capabilities, which you can use to create your own custom capabilities. It's a vehicle for delivering high quality reusable software. And you should think of it as a hierarchical software framework to enhance software interoperability and quality expectations. And a conduit for future leading edge HPC software targeting scalable computing systems. Looking forward, we want to deliver DOE reusable software as a portfolio, and E4S is ready to extend to next generation software and hardware needs. And we are looking at DOE software as a portfolio, and it's a first-class entity in the ecosystem now, and we have good cooperation and support from the vendors, and we would like to support this on all the relevant HPC systems. So in short, I would like to say that E4S is a curated software stack with quality improvement incentives moving toward turnkey use, and with DOE program managers, ECP starting software ecosystem sustainability planning, and Mike mentioned a lot of that, the E4S strategic planning. We believe that E4S has reduced important gaps that limit usefulness of DOE software for industry. We are trying to address the other gaps that remain and explore these gaps and work towards improving E4S. And I would like to thank the Exascale Computing Project for their sponsorship of E4S. With this, I'll take any questions. Here is the install on Perlmutter. And you can just do that, but I'll just show that it's using the MPI libraries. But let me just pause here, and we still have a few minutes to wrap up, and I'll take any questions, or if you have any issues with the hands-on. If you would like to try this, feel free to go and try the session on Cori with Shifter and try this entire test suite with Zoltan application. Any questions?
Just a quick question on how robust the hashes are, in that if somebody were to try to use the binary caches to install locally on a system whose configuration is different from your runner systems, how likely is it that the hashes will be very different and none of the binary packages will be able to be installed?
So, you know, the first important thing that you should match is the compiler. We have different compiler versions for the given operating system. You have, if you have a match over here, this is just an example of a package called Butterfly Pack. And you can see all the hashes over here for different operating system versions. If you get the OS right, the compiler right, and the architecture like x86-64, then there's a good chance that you will be able to match the hash. And you are absolutely right. The concretization is a significant process, and the Spac team is always trying to come up with the best way to concretize and reduce the time for concretizing the entire recipe. They now have a Klingo-based concretizer, as you may be aware. But if the hashes do not match, then you will need to recompile from source code. And you're right. So it's an important issue for concretization. I think the Spac team can speak more about this. We are users of Spac, so we are creating all these binaries and posting them on our web page. So there is a good chance that it might match because we have so many different variations of compilers and runtime systems. If you want to use the exact same version, you could just try using the exact same version of Spac and the operating system and compilers. And then there is a good chance that the hashes will match. Did I answer your question?
Yes, though in my experience, maybe I'm very unlucky. I've been forced to go down the rebuild path once too many times. And the worst part is when I try to do the rebuild path, not everything works. So
and you know,
if one package doesn't work, then dependent packages also don't work. So I wish there was a very robust way to install binaries. So I would just say, okay, I got them all. But
we would like to work with you and make sure that that our build caches support your specific architecture and versions. And please reach out to us, and we'll, if there are issues with the build cache, we'll build those packages for you and post them in our build cache. But sometimes you might find that the container release can help fix some of those issues. If you, for example, were using on Cori, you were using the shifter with our 21.08 image. Now you've nailed down Spac. You have nailed down the compilers. You have nailed down the architecture and the operating system. With all of those things nailed down, there is a better chance that the Spac concretizer will match your specific Spac.yaml file.
okay, thank you. I will reach out.
Sure. Any other questions that I can answer? We have the last 10 minutes remaining. Helen, I should mention to you that you asked a question about containers and installation of E4S on the other TriLab sites. And I have accounts on these systems where in my accounts, we have installed the Singularity containers on all three of these sites. So if you were interested in using the containerized workflow with E4S, it is immediately available to you. Did that help? Can that help?
Yeah, thanks. Yeah. So that was already answered also. I was basically trying to ask a high level question within DOE ECP, why we chose 3 labs, not all the labs. What is the plan? So,
and with the E4S container, with this large collection of 88 packages, you'll find that using Singularity also provides a viable option for the TriLabs.
Definitely, yes. I was just saying, if there would be like installed packages just like E4S stack on NERSC systems, would those be available on the other labs besides Oak Ridge and Argonne?
So with the container, I'm just downloading a single file, and it's very easy to just have Singularity installed and a single file, and then you're ready to go. But supporting the entire set of packages will require a great deal of involvement from the HI team, and I can't speak for them. And Ryan should get back to you on that process. But do reach out to me if you have any questions for specific machines, and I'll show you an example workflow with E4S on those systems, so you can try the Singularity-based container deployment approach.
Yes. So I think Ryan did answer. I think it probably will be available on El Capitan or Frontier down the road. That's my impression.
Sounds good.
Yeah, and that's lots of work from all these people involved. I think it could be an ongoing process.
Sure. And even on systems, early access systems where the software stack is being built, you can see that having a shifter-based container deployment while the rest of the packages are being built on Perlmutter can be a very good way to get started. And even within the container where I'm on Perlmutter, I can see this is the Ubuntu-based E4S deployment. And I can access the GPU, the A100 GPU running on Perlmutter through the container image, through Shifter. So
Yeah.
When you see this Spac find, and we have with the container, you have all of these packages that you can access and build, then it gives you a great deal of flexibility in installing your applications, even while we wait for the bare metal installs.
So yes, I think Gitlab is also, of course, working on doing the native install Perlmutter.
Absolutely.
But I think the container mechanism is also very portable for other systems. Impressive, yeah, lots of good products here.
Thank you. And I have a comment here from Wyatt where he says that I recall hearing that the Spac team was working on support for more flexible support for the binary cache. So perfect hash matches might not be necessary. And yes, that's a issue we have raised with the Spac team, saying that if my build cache has support for GCC 930 and I'm using 931, and I say that I know that there is not such a big difference between the minor versions, that I would be okay, even if the compiler is not matching perfectly and the hashes don't match. Can you force that with a, like a -F flag, force me to specify a hash and say, please don't bother matching it perfectly, use the build cache anyway, and I'm willing to take that risk. So they are working on a mechanism that will allow us to do that. So that might even help some of the other cases that that were mentioned earlier. Any other comments? Shazab, do you have any closing remarks for?
No, I guess, do any of you have any questions for any of the other speakers?
Well, I would like to thank the ECP team for organizing this session. Ashley, Osni, thank you very much for inviting all of us. And please let us know how we can assist in future training workshops.
Sure. Thank you, Samir.
Yeah, thank you very much.
Mike, do you have any other closing remarks for this?